Good to have you with us in the 9 p.m. edition of the Urban Debate. It's been a long-standing joke, viewers, of how our Met department gets its weather forecast wrong. So much so that people often say that the DTH cable operators are perhaps better at telling us when it's going to rain because they go off the minute we even see a single drop of rainfall, even before the Met department. Those are the jokes. Obviously, our weather forecasting agencies do a much better job than that. There is a lot on their plate. Everything in terms of planning, from our farming season, agriculture, sowing, harvesting, transport, to various other parts of economic activities, to travel plans, to disaster relief management, to preparing for any kind of big disasters that take place, to planning to what extent do you allow your dams to fill up with water, when do you release that water. All of these things and so much more is really dependent on weather forecasting and accurate weather forecasting, accurate weather prediction. And for most of it, it does go right. But it's also one of those things that when it doesn't, it gets highlighted, which is probably what you see with the IMD or even some of the other agencies that we have. When we are prepared for heavy rainfall and water logging, because we've been told there is a red alert, but the rains doesn't come and we're all going about our day planning it in such a manner that we will be stuck with knee-deep water and doesn't happen, we do get frustrated and we do ask this question, how did we get this wrong? So tonight we decided that we're going to, for the next 30 minutes, put the spotlight on weather forecasting, on weather prediction, and ask how prepared are our agencies, IMD and others. What are the new systems which are out there? How is it in some of the other countries you get weather predictions, for the next 2 to 3 hours and next 4 hours, and which are always so right, but ours isn't? Or is that just a general perception that people have, which is not correct? So we decided to bring in the experts and help us understand. Now, why are we doing this today? That's because the IMD itself admits that, in predicting arrival of monsoon and monsoon this year covering the entire country, they did get the timeline a little wrong. Monsoons were 15 days later. They arrived 15 days later for most parts of the country, especially northern India, than what IMD had predicted. And of course, there will be changes as weather changes, as monsoon progresses, as clouds move from one part to the other, as winds move, as storms get created. Sometimes these predictions can change, which happens everywhere. But did it have to happen to this extent? IMD itself says predictions going wrong are rare and anomaly, but it did happen. And it does become problematic, like I said, for various reasons. For longer time planning, for mid-term planning, for immediate planning, from the biggest of the agencies planning economics and policies and agriculture for our country, to every day for the common man itself, whether to step out, at what time to step out, and how to go about planning their day. So gaps in data, substandard equipment, non-functional equipment, lack of software professionals, models which are not fine-tuned to our kind of conditions, so people who are not trained to read into the equipment that has been given to them. There can be many reasons. How much of this have we managed to fix, and what do we need to fix? That's the question I have. Let's say good evening to G.P. Sharma, President of Skymet, joining us this evening, Dr. Abhilash, Director for Advanced Center for Atmospheric Radar Research, K. Siddhartha, Earth Scientist, author for Climatology, Atmosphere, Weather and Climate, and Dr. Laxman Singh Rathore, former DG of IMD. And Dr. Rathore, I want to start off with you. Good evening, and thank you so much for joining us. You have the most insights into the functioning of IMD, the challenges that are there than any of us. So help us understand what did you make of the predictions this year and how they kept going off the mark?
Well, anomalies are part of integral part of the prediction failure, no doubt about it. Understanding weather is a difficult task, and any forecasting agency has to deal with uncertainties, and more the uncertainties, less the predictability. That is a general rule. But what has happened monsoon 2021 is the question in focus. Well, every monsoon is different. So also monsoon 2021. And there are certain standard procedures for predicting monsoon onsets. And also there are, we know that in the recent past, the onset dates have been modified primarily because of climate change. The monsoon onset, arrival of the monsoon has delayed on an average, particularly over central part of the country. So therefore, point I want to make is that the monsoon is changing its characteristics and also the behavior. Predicting a kind of a normal synoptic situations is easy. At times, there are conditions when the anomalies are immediately faced in a very pronounced manner. And I think this monsoon is one of those categories. So operational forecasters will always face that kind of difficulties. And these days, the operational forecasters are much dependent on the numerical models output. And the models, and they unfortunately, most of the models have failed in predicting the right onset dates this year, and including the ensemble, which is a gist of the best of the model's performance. Different agencies prepare those ensembles in different ways, but there is definitely a failure on that account. And so therefore the dependence on, huge dependence on the numerical model output really at times misguides you, and we are really these days missing out the good synopticians who, because forecasting is always a man-machine mix approach where you take the model output and apply a lot of human intelligence. So somehow, if you don't apply those intelligence and really do a good analysis of synoptic features, the failure is more loud.
Okay.
That's what I understand.
Very interesting point that you made. So you said a part of it is also, of course, because of climate change, seasons and season movement, monsoon movement has become more unpredictable and changes. But there is also the other aspect where we maybe, Mr. G.P. Sharma, we are over-dependent on these database models without really, mixing it with manual expertise. Would you agree that can also be one of the reasons?
See, Tanvi, what Dr. Rathore mentioned very rightly, okay, backbone now is your numerical weather model. There is no doubt about that. And you see what we started off with, say about 2 decades back or so, everybody has added the computing power. Be it IMD, the supercomputers are there, be it Skymet, we have added tremendous amount of computing power. And then therefore there is a change. It was about 2 decades back, and now obviously there is a sea change. Okay. We say predictions, IMD prediction going wrong. I don't agree with that straight away. It's a part of the game. Okay. It's everybody, it's a very, very scientific. If a person is giving a forecast, the person, sure enough, he goes in a scientific way, and there is tremendous amount of human also skills being added to the model predictions when the data is available. Okay. So let us not doubt that. But then predictions are likely to go wrong at times. They have been right in the beginning, whether it was the onset, whether it is the further progress. Far too many, the first 2 phases of the monsoon, I will say it was spot on. First 10 days itself, the monsoon covered 80% of the country as such. Only in the last phase, okay, the problem came when we predicted that, okay, monsoon is likely to reach Delhi on 15th of June and didn't happen. And that's how led to the problem, because it was not inching forward thereafter. It was just about stationary and didn't budge from there. In the past, there have been, in 2008, the monsoon reached Delhi around 15th of June. In 2013, it reached around 15th of June. So it was no different this time also. And then what we see now also, for the last few days, what a common man and me and you possibly look for is the rains.
Yes.
Monsoon is not only rains about it. Monsoon changes are there in the air. They were very, very visible in Delhi for the last many days. Winds were easterlies, humidity had increased, clouds were hanging around. There are all these parameters. They speak for the monsoon arrival. The only thing missing was, yes, which it did not manifest itself into widespread rains also, because some patchy showers were there here and there, but obviously in their prudence, I think IMD waited for the good amount of rains, and that's okay. But otherwise, let's take it that monsoon definitely change was there in the air before this also. Even 4-5 days before, it was definitely, it is there.
Okay.
And then, yeah, tell me.
Okay, so I will come back to you because I have follow-ups, to you as well as Dr. Rathore. But let me just bring in our other two panelists as well. Dr. Abhilash, many instances are given of what's happened in the recent past that people do remember, and of course a lot of other reasons may go behind it. But from where we see it, one can turn around and say, when it was the time for Cyclone Tauktae, the weather forecasting agencies, and not just IMD, but everybody had trouble in and around of Mumbai and Maharashtra because some of the radars which are required and the equipment that's required wasn't functional. Similarly, for Cyclone Nisarga, we seem to have been off. Gotten it wrong 48 hours in terms of when it will land. But again, the same radar was not functional. There was a difference in the way winters were predicted for North India in 2019. Even in the monsoon that was predicted at that time, when they said it will be normal, but it ended up being with an excess of 110%. So how do we read this? Some amount of equipment, outdated equipment as well, and some amount of climate change and just unreliable weather?
Yeah, actually, I do agree with Rathore Saab. Thing is that if you consider monsoon as a system, it is composed of different scales of the activity combined together. So, if you put the question in such it's this way, like that, if you are predicting a system, the predictability also depends on, not only depends on the tool which we are using, it also depends on the system itself. So if you consider Indian summer monsoon for maybe for the last 10 or 15 years, we can see that there are a lot of variability inbuilt or inherent within the system itself. If you look at 2015 monsoon, we can find that we are talking about the interannual variability of the monsoon, which is an inherent part of monsoon variability. But at the same time, if you look at the prediction skill of different models,
seem to have lost that feed. Yes, okay, Dr. Abhilash, I think you're back. Go ahead. Your machine, I think you've gone on mute again. Can you just check?
Yeah.
Yeah, okay.
Yeah. Actually, what we are looking at the variability. If you look at the interannual variability of the monsoon, you will not get the same amount of monsoon every year. Similarly, if you look at the skill of the prediction model, there can be different models, like many models, US model, European Center model, Japanese model. Each of this model has different skill during different years. So the skill of the model is also varying interannually. You will not get the same skill next year. It depends on the system. That is what, if you look at, if you consider this problem at a shooting problem, if your target, you are selecting your tool for depending on your target. If your target is more visible, you can have a fine machine gun or rifle, you can shoot the target. But it depends on the target also. It is not depending on your tool. If in this case, the monsoon system is the target. This target itself is having different variability on different scale. If the synoptic variability is dominating, then there are a lot of noise. If you look at the season as a whole, in which synoptic variability is like 40, 50, or 60%, then the predictability of the seasonal scale will reduce. So that is what happened in 2015. Though the system was predicted as such a in good state, but the predictability of this synoptic activity is very limited. So that means if every monsoon system, if every monsoon season, the predictability of the system is the important factor we have to take into account. So whether
right, okay. So, okay, but can that be improved? Can this be improved by better trained professionals, or different kind of equipment that perhaps exists somewhere else?
Yeah, this is actually a science problem. So
yeah.
What we are putting before us is a science problem. As Rathore sir was telling, it consists of lot of uncertainty. This uncertainty itself is composed of two parts. One part is due to the deficiency or the inaccuracy in your model initial condition. That depends on, as you are telling about, that depends on the equipments or the observational system we have. So if it depends on the observational capability, which is entirely depends on an initial value problem, then another question is your model. The model what we are IMD or Skymet or any other agency is using, they are using it over the years. They are refining it. They do hindcast to analyze their past performance. Then they make corrections. Then they make bias correction, anomaly correction. Everything they do regularly. But this model itself has got some of the inherent inability in properly representing the physical process happening in the monsoon system. So if that physical process happening in the monsoon system is mostly of a noise kind of transient kind of synoptic kind of system, then the predictability of the model itself will reduce. So that is what the combination of the problem is like. It is coming from two aspects. One is from, as you rightly said, the observational capability, the data continuity, the data distribution, everything depends. But at the same time, you have to fine tune the model to capture this synoptic scale, the temporal scale evolution of the system. These together only will make a more robust system for future prediction. So we are improving over the last 10 years with the advancement of different type of satellite system, radar system, and the high performance computer system. We are more advanced compared to last 10 years. But
sure, we have a longer way to go. We've come a long way in 2016, I believe. Even in 2017, some new systems were put into place. But Mr. Siddhartha, do you believe we have a long way to go in terms of putting in better systems and technology? Or is a lot of it also to do with climate change and something that we can't really help, and we need to change how we view it, how we predict it, and how we plan?
Well, I consider parts of the issue. The first part is the technology part, and the gentlemen that we have in the panel, they are much better equipped to talk about it because they have played with that type of a technology. But then, as far as technology is concerned, there is a problem because at a block level, there is a technology problem. We are not able to have that much amount of data. We are also not in a position to process it. And as most of these are talking about synoptic, we don't going to be having people who can go to observe these data. And after having observed it, they can go on to make out not exactly a prediction, but they can go on to make it out that this is how the weather is going to be. Now, this is what exactly is lacking in our system right now. You will not believe it, but some time back, some 500, 600 years back, and 1,000 years back as well, people used to be predicting it almost on a daily basis in the rural areas of the country. I know it because I have researched that part, and that was they had a lot of folklores. These type of folklores used to be going on and on in the villages, and all the children used to learn it. That's number one. Second is, when you talked about this inherent characteristic of it, we're going to talk about that monsoons are not uncertain. Monsoons have a high degree of spatial and temporal variations. To call anything natural by a judgmental word as uncertain is not fair. So they are variable. And they have to be variable because it's a tropical system. A tropical system by its very nature and ultimately goes on to get itself destabilized the moment it goes on to get itself generated. It's not like a temperate region. You cannot go on to have same type of a climatic smoothness or predictability that you can go to find in Britain, that you can go to find in even Germany, you can go to find in Vancouver. This is largely not possible because the temperate systems are much better adjusted to it. You can predict it the way that you predict it in winter season, that this is the time when the western disturbances are going to be coming. So a tropical system depends on a system like that of monsoon. Can you imagine? It depends on how much amount of reflectivity is going to be in the Tibetan Plateau region, how much amount of snow cover is going to be in the Himalayan region, how much amount of low pressure, high pressure, the amount of moisture of the coast of Somali, whether it is going to be Indian Ocean is warm on the western side or eastern side. You consider the number of variables that is going to be affecting monsoons. There is no system in the entire of the world that goes to be affected by that number of bewildering variety of variables as the monsoon is going to be impacted by. And there may be some of them that we don't going to know as well. But that is going to be a long term. Long term, we do not going to find an issue because we are able to predict tropical cyclones. We are able to predict the western disturbances. We are able to predict that this time the monsoon will going to become weak because the tropical monsoons, the tropical cyclones have come in the way of the monsoon. This is something that we have been able to do it so. Now, we have been pretty certain in this case, that is, public perception is with respect to some of these, putting some type of a blame and putting memes in it. But then people do not go to understand that monsoons may be hitting at the door of Delhi. And then you have an air circulation which has been aggravated by some of these dry winds coming from the Arabian region. And these dry winds are able to push the wet regions or wet winds or humid winds which are coming from the Bay of Bengal region. Consequently, they're going to dominate. And that has been the factor. The basic factor in Delhi and other regions has been that the air has not been rising. It has not been rising fast enough so that it can go to lead to formation of clouds. And it can also go to lead to formation of maybe cumulonimbus clouds or a stratus cloud. The pattern that we see it changing right now is that most of the rains some time back used to be taking place through stratus clouds some time back, 15, 20, 30 years back. Now, the rains have gone on to become concentrated, and that goes on to take place in the form of a cumulonimbus shower. That is intense, and that is very heavy for only some amount of time, but that is what is going to be.
Yes.
So as I will go on to conclude it in this manner, that is, there is nothing wrong with our prediction system, because a prediction system that is based on tropical meteorology is bound to be, if you call monsoons as uncertain, then this is also going to be uncertain. But then uncertainty is the beauty of the monsoon. Monsoon have been uncertain even 1 lakh year before, and that will be uncertain even 1 lakh year ahead as well. There is nothing that can go to
Okay,
change.
so I want to now take the conversation beyond just saying, okay, predicting the monsoons, Mr. Rathore, beyond just saying that, okay, I'm not just talking about when the monsoons will arrive or how normal or excessive or dry will they be and when will they cover the whole country. But as far as the larger weather forecasting goes, and I ask you this question, Dr. Rathore, because people often say, oh, if IMD said something, then that's definitely not going to happen. Help us understand why it's so difficult, or whether you do see space for improvement in forecasting, considering that so much more science and technology and equipment is available today.
My previous speakers have underlined the fact that the tropical region, we have barotropic instability, and all weather features associated with this kind of instability are less predictable. Let us understand that. Number two is with the global warming, this understanding of our instabilities and the thermodynamics and hydrodynamics, and also the continuity of the atmospheric systems go hayway. That means our understanding, which we have developed over the last few decades and docketed in the form of models, which is a very good account of process-based physics and thermodynamics, hydrodynamics, continuity, etc. That's how the models are synthesized, and they are capable of capturing most of the things well. And as Abhilash also underlined, that initial conditions, which are very important, and initial conditions are defined through the observations. So therefore, what should we do in future to further improve or beat out these challenges? Number one is enhance our observing systems and also improve our understanding of this changed behavior which has been entered into because of the global warming. And as we know that monsoon is directly linked to the large memory of prediction resides in the oceans. Indian Ocean, of course, is prime because the monsoon originates from Indian Ocean, so Indian Ocean dipole, and then the Pacific, we have El Nino, Nino, and also the Atlantic Nino. So understanding of the thermal behavior of these oceans, and particularly in the southern hemisphere and central equatorial region, etc., are very important. And then because they are impacting its linkage to atmospheric processes. So first thing is we need to have a more accurate understanding. We did MONEX in 1979, and then we did Bay of Bengal experiment and Arabian Sea experiment. I think it is the right time now to conduct an international experiment on the monsoon by all the countries putting their resources together to understand these linkages in the changed atmosphere. That is very important, number one. Number two is the role of synopticians, as I mentioned, and now these days it is the artificial intelligence which are getting more pronounced in understanding and linking the behavior of past synoptic systems and with that information pools, linking that to further fine-tune the model output, which we call as post-processing. So blending these two things, rather three things, improved observations, because now our reliance on satellite and other remote sensing observations are getting more pronounced. And so, but the ground truthing, though maybe less in number, but very accurate ground truthing is very important. And then data assimilation, because if you are by any chance ingesting wrong data into the model, the results are definitely going to be wronger. And the defining initial condition, let alone the forecast accuracy, I say the initial condition defining itself, we have large amount of errors. We have to minimize that errors. It is very important.
So enhance our observing systems, improve understanding of changes due to global warming, understanding, that also will include evolving changes in terms of the thermal behavior of the oceans, collaborative global study to really look at these changes and understand them better to build our systems, and better trained synopticians. I am a little short on time. Mr. Sharma, would you like to add to this? Anything else that you think we can do?
Yes. Ms. Tanvi, monsoon, let's understand, it's a very, very complex, 4 months long, and then in any case, it is more than 4 months, I will say. It starts sometime in middle of May also. Your Bay Islands, this side, 15th of May, sometime around is the date. Monsoon withdraws around 15th of October from the country. It's about 5-month long season. Having prediction for such a complex and such a long particular phenomena, which lasts for 5 months, forecast for this particular thing comes even 2 months before that. Can you imagine? April month, the forecast comes from the IMD. We also in Skymet, we issue in the first week of April for a period of 4 months or more. So let us understand the complexity of the systems, and therefore their course corrections are required. We should be prepared for even some deviations in the predictions if they are made. As long as we are able to understand the problem correctly from season to season and apply some course correction whenever needed, I think we should be doing the needful in this direction.
Okay.
Yeah.
Great. Air Vice Marshal G.P. Sharma, thank you so much for adding to that. Dr. Rathore, thank you for joining us, and a big thank you to, in fact, all our guests, Dr. Abhilash and Mr. Siddhartha. Suffice to say, experts will tell you it's not easy. It's not an easy science. It's not easy to make these predictions, especially when it comes to monsoons. We largely get it right, but there are still several steps that we can take, not just for more accurate and timely predictions of monsoons, but in general for weather forecasting. And we must do that as we also witness climate change because of global warming. We need to keep updated, with the changing times. Completely out of time. Thank you for joining us on this conversation.